All right, welcome to lecture 30, part B. All right, the main thing we're going to do in this part, and actually in the very last one, we're going to talk about the pH scale. So we'll get to that in just a minute. Now, before we get started, you know what? Let's do a little review question from part A. Let's do a little review question from part A. So let me flip over to that. All right, so this one says, oh, it has to do with those ions we were talking about in the first part, part A. A solution with a hydronium ion concentration of 4.5 times 10 to the minus 4 can be described as, is it basic, acidic, or neutral? Think about it. Think about it. Oh, what would it be? All right, well, the way you can figure this out again without doing any math at all, take this number, compare it to what you find in something that's neutral. I'm talking about, like, for example, water. In water, the amount of hydronium ion is 1 times 10 to the minus 7. In this solution, the amount of hydronium ion, maybe I should write it like this. So this is in water. In this solution, the amount of hydronium ion is 4.5 times 10 to the minus 4. So where is it more? You have more hydronium ion in this solution. This number is bigger than this number. So in this solution, there is a greater amount of H3O plus. When you got a whole lot of H3O plus, what are you? You're acidic. So it should have been acidic. All right. All right. So with that, let's get into the topic I want to talk about, which is pH. Now, if you look so far, what we've been doing, we've been talking about these two ions, right? We've been talking about hydronium. We've been talking about hydroxide. And when we've talked about the amounts maybe sometimes are a little hard to think about because in any solution, the amounts are always like really small. And when you have like these small numbers with like scientific notation and exponents, sometimes interpreting what these numbers mean and which one is bigger than the other one, that's not always so simple. So one way that we can interpret, or kind of, I guess I should say, talk about acids and bases without having to look at these tiny values is the pH scale. So the pH scale is another way of talking about, are you acidic or basic? But the numbers we're going to run across aren't so kind of crazy and always in scientific notation and so on. All right. So first off, let me just tell you, the pH scale goes from 1 to 14. 1 to 14. If you are neutral, you will have a pH of 7. Things with a pH of 7 are neutral. Now, if you have a pH less than 7, anything less than 7, 1 to 6.9, you are acidic. Now, the closer you get to 1, the more acidic you are. All right, so if you're just a little bit less than 7, you're slightly acidic. If you are way less than 7, like 1 or 2, you're really acidic, strongly acidic. So the most acidic things are going to have really low values, like a pH of 1, for example. Now, if we move around from 7, which is neutral, and we go in the other direction, that's where we find things that are basic. A little bit more than 7, you're just a little bit basic, weakly basic. If you're way more than 7, you are strongly basic. You're very basic. Now, so you notice kind of the extremes are on the ends. Way acidic, a pH of 1 or 2. Way basic, a pH of like 14. All right. Now, like, where do you change from being weakly basic to strongly basic? There's no like cutoff. The further you go, the more you get basic to the right. The further you go to the left, the more acidic you get. All right, so we're going to learn how to calculate it. And actually, the way you calculate pH, pH is related to one of those ions we've been talking about. It actually is related to the amount of hydronium ion, H3O plus. Now, more specifically, it's the negative log of hydronium. So P is actually a mathematical function whenever you see p. P means take the negative log of something. So right now we're taking the negative log of like hydrogen, or we could write H3O plus. So the negative log of hydronium, that's what the pH is. So pH relates to the amount of hydronium. Now, I should tell you, we haven't had to take logs much in this class, or I don't know if we ever really done it, honestly. So I'm going to kind of try to explain it to you, but I should warn you, every calculator works a little different. So if you're struggling on how am I coming up with these answers, you can talk to me in Zoom or send me an email. All the calculators in the world work a little bit different as far as how you take and enter logs on your calculator. So just be aware of that. All right, with that, let's go ahead and move on. pH is the negative log of hydronium. Let's move on. All right, a few more things, and then we're going to actually do some calculations with pH. But before we get to that, let me mention a couple more things, which is the pH scale is like a logarithmic scale. So, what does that mean? It's sort of like when we measure earthquakes, that's also a log scale. So do you know how like a magnitude 6 earthquake is way stronger than a magnitude 5 earthquake? Or a magnitude 7 earthquake is way stronger than a magnitude 6 earthquake? Well, that's kind of how pH works. Every time you go from, let's say, a pH of 4 to 3, that's not just getting a little bit more acidic. Remember, the lower the number, the more acidic you are. It's actually getting way more acidic. So if you go from 4 to 3, you're actually becoming 10 times as acidic. There's 10 times as much hydronium. So the amount of hydronium goes up by a huge amount, by a factor of 10. Now, same thing, if we go from 3 to 2, the amount of hydronium, it might just sound, oh, pH of 2 to 3, that's not much different, right? But it's a log scale. So not only have you gone from 2 to 3 on the pH scale, as far as the amount of hydronium, it actually becomes 10 times as much hydronium again. So like it changes by a factor of 10 yet again. So what if you were to go all the way from 4 to 2? Well, you go up by a factor of 10 and then a factor of 10 again. You actually change by 100. The amount of hydronium ions would be 100 times as much, all right, in something that has a pH of 2 to 4. So when we do these calculations or when you see some numbers, keep in mind that if you see pHs that kind of seem kind of close to each other, they may not really be that similar. You might have a dramatically higher amount of hydronium, even though your pHs don't seem all that different. All right, so let's take a couple other things I want to point out to you. Like what are some like pHs of some things around your house? Well, again, if you have a pH between 1 and, well, up to 7, I guess we'll call it 6.9, you're acidic. The closer you are to 1, the more acidic you are. So like gastric juice, that's juice in your stomach, it has a pH of like 1.6. That's really acidic. Lemon juice, things that are sour are acidic. So lemon juice, really sour, it has a pH of about 2.2. If you drink coffee, it's also acidic. It has a pH of like 5. So not nearly as acidic, but it's still acidic. It's, I guess we'd call it weakly acidic. Water, pure water is neutral. And then when we get above 7, you become basic. A little bit above 7, slightly basic. That would be something like, I don't know, blood is slightly basic, or ocean water is slightly basic. pHs of like 7 and 8. And then when you go way above 7, you become really basic, like bleach. Bleach has a pH of 12, so that's really basic, or like Drano is really basic. It has a pH of 14. All right, so hopefully this gets you a little feel for how the pH scale works. Let me point out one more thing to you, and that is, again, the pH relates to the concentration of hydronium. All right, now, in a little bit, we're going to learn how to calculate pH and hydronium, how to actually work it out on a calculator. But just to give you a sense of it, if you have a pH of 7, what does that mean? It means you're neutral. And it means, remember this from earlier, I guess part A, it means the amount of hydronium ion and hydroxide ion are 10 to the minus 7. Now, when we get to something that's basic, a pH of 8 or 9 or 10 or 11 or whatever, the amount of OH is getting bigger the further we go. So these numbers are actually getting bigger. This is increasing. So this would be increasing. And then as we go to the right and we become more and more basic, the amount of hydronium is actually decreasing. So you notice they kind of do opposites, don't they? OH and hydronium. Now, if we go the other direction, it's flipped. A pH of 6 and 5 and 4 and 3 and 2 and 1, you're becoming more and more acidic. What happens when you become more and more acidic? Hydronium keeps getting bigger and bigger and bigger. And the amount of hydroxide becomes lower and lower and lower. Less and less. I guess I should say it decreases to be consistent. It decreases. All right. So with that, in this video, I think I'll show you maybe one math example about how to calculate it, and then we'll get into most of the calculations next time, okay? All right, so hopefully this gives you a little feel for the way pH works. It can be a little tricky at first. Let's just do a little practice question. Let's see if we can calculate pH, all right? Let's flip over. How exactly do you calculate pH? I know it has something to do with these ions. All right, let's talk about it. All right, so let's calculate pH. All right, so remember the formula for pH? I already put it up once. Let's put it up again. The pH of something is just the negative log of hydronium, H3O+. All right, so it says a solution has a concentration of hydronium of 3.2 times 10 to the minus 12. What's the pH? What's the pH? So they tell us the amount of hydronium, so we'll put that in right here, 3.2 times 10 to the minus 12. And then it says pH is just the negative log of that number. pH is the negative log of that number. Now, again, depending on what calculator you own, what calculator you went and bought, the way you enter this on your calculator could be a little bit different. Let me tell you the two common ways. If you have the same calculator I've been using all semester, this is the way you're going to enter it. First thing you're going to do is you're going to type in the number. So that would be 3.2 EE minus 12. Type in that number. Then you're going to hit the log button. Now, again, this is not going to show up too well, but hey, man, there's a log button on your calculator, I promise. It says LOG. On mine, if you have mine, it's on the top row right there. That log button right there. All right. Now, there is an LN button. You might have used that in a math class or something. Different. Not LN. LOG is the one you're looking for. Now, after you hit the log button, we're going to also reverse the sign because it's actually the negative log. So you'll hit the log button, and then the last thing you'll do is you can either reverse the sign in your head, honestly, or on your calculator, there's like a plus minus button that would do it. All right, so let me do it on my calculator. All right, I enter the number. 3.2, you know, you can't really see this. EE, negative 12. Hit the log button. All right, hit the log button. When you hit the log button, that's what it says, I hope. After you hit the log button, then the last thing you do is you hit the plus minus key to reverse the sign. My answer should turn out to be 11.49. All right, I'm not going to get into the rounding. There are some rules for rounding, but let's not get into those right now. All right, so 11.49. Now, if you're like, my calculator didn't do anything, it gave me an error message. It is certainly possible, if you went out and bought a different calculator than me, that you actually have to enter it the other way. You might want to hit the plus minus key first, and then hit the log button, and then you type in the number. All right, it's possible you have to kind of do it the other direction. All right, so I don't know which way your calculator works. Well, I know if you have my calculator, you're going to do it this way. Number, log, plus minus button. But another brand of calculator, you might not go this way. Negative, log, and then type in the number. Try it one way or the other, guys. You should be getting 11.49. If you're not getting 11.49, You and your calculator are not in a good relationship. You're having a problem. You need a little marriage intervention. That's what I'm here for. You can send me an email, send me the brand of calculator, I'll figure it out for you. Or your other option is you like Google log on a Casio 53 or whatever it is, and maybe, a little video on YouTube will show you, or you'll find the directions or whatever. Okay, with that, in the next part C, we're going to see some examples like that. So in part C, we'll do more math problems. So I'll show you a few more. Now, to wrap up this one, though, let's just do one little practice question here at the end. And really, what is all this about? What this is all about is different ways of understanding, determining whether something is an acid or a base. So in this one, it says, I have told you that, let's see here, several facts, like HCl has a pH of 1.5. And I want to figure out whether that means HCl is acidic, basic, or neutral. And I might tell you, pancreatic fluid, the amount of hydronium ion is this number, 1 × 10⁻⁸. What does that mean? Is that stuff in your pancreas acidic, basic, or neutral? Or what if you have Evian bottled water? You can buy that fancy bottled water from France. That's got a pH of 8.1 actually. Is that acidic, basic, or neutral? All right. So let's see if you can do it. Let's see if this makes sense. You're gonna get these pop-up questions, and then we'll go over them in a minute. All right. So number A, HCl has a pH of 1.5. Is that acidic, basic, or neutral? Okay. If you have a pH between 1 and 7, you are acidic. All right. So that would be acidic, or I guess I said 1.69. If you're 7, you're actually neutral. So 1.69 is acidic. All right. All right. Number B, pancreatic fluid. The amount of hydronium ions in pancreatic fluid is 1 × 10⁻⁸. What is that telling you? Acidic, basic, or neutral? All right. Well, how do you figure that out? Well, one way again, and this was kind of actually in the last part, wasn't it? If the amount of hydronium ion is in neutral water is 1 × 10⁻⁷. Now in this pancreatic fluid, the amount of hydronium ion is 1 × 10⁻⁸. 1 × 10⁻⁸, that's actually less. So you have less hydronium ion than in something that's neutral. If you have less hydronium ion than in something that's neutral, you're actually basic. You don't have as much hydronium as you could. If you had extra hydronium ion, you'd be acidic. But this thing's got less, so it's basic. All right. All right, last one. Evian, bottled water. It's got a pH of 8.1. Acidic, basic, or neutral? Should be basic. So anything with a pH of above 7 all the way to 14, you are basic. All right. So lots of different ways, lots of different numbers floating around, lots of different things like hydronium hydroxide. All that can be confusing. So that's why you got to kind of think about this and practice a little bit. All right, so that's it for part B. This is kind of the introduction to pH. The next part C, we're going to do some more calculations with pH, get a little better at that. So if you have any trouble with this or you're confused, let me know. This might be one of these ones where you need to kind of rewatch it, or at least parts of this video, for it to really sink in. I wouldn't blame you if you did. All right, have a great day. I'll talk to you in part C.